Having realized that f prime of x, or the derivative of a function, is something we can compute fairly frequently, we haven't shown how yet, but it seems to make sense that for a continuous and smooth function that we'll have derivative values. The next question is, what would they mean? Well, we get some really nice direct connections between the shape of the graph and the derivative values through this table here. When the derivative of x is greater than 0, or the derivative is positive, what we can say is the function is increasing. And again, that shouldn't be a huge surprise, because derivative is positive means the slopes of tangent lines to our function are also positive. And anytime you have slopes that are positive, you're talking about something that's not flat, but positive slope, and therefore increasing as you move from left to right. So this increasing here implies from left to right. And just the opposite occurs when you have negative derivative values. Why? Because the slopes of the tangent lines to f of x are negative instead, and under those conditions, you have negative slopes, and as you move from left to right, your function will be decreasing. And then we have those special transition points where the derivative is 0, and that is when the tangent lines to the graph is horizontal. And again, horizontal, slope 0. Those two things are equivalent. We're going to give those particular points a special name. F of x is going to have a critical point whenever we find a point where the slope is 0. All right, let's do a quick analysis here just to use those concepts. We've got a graph like so, and we can ask, well, in what intervals is f prime of x greater than 0? Your first exercise is simply to translate that into words. When is f of x increasing? All right, so which points is the derivative positive? Well, it's the points where, or the points at which the function is increasing. And it's pretty clear, I think, as you move from left to right, that we're going up, 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 and we stop just before b. The slope would be 0 at b. Then we're going down, so negative derivatives, and then positive. You have to be a bit careful just to adjust your eye here. All along here, if we were to draw tangent lines, the tangent lines would be positive, and then we would stop just before f. So from a to b and from d to f are the intervals where this function is increasing. We can ask related questions like, where does f prime of x take on its largest negative value? And again, interpreting that derivative as a slope value, when is the slope the most steep? Okay, so when we say largest value, we're talking about most steep, but we have the additional ingredient that has to be negative. When is the slope most steep and negative, or pointing downhill? And I think on this particular example, it's pretty clear cut. When we're up here, the slopes are fairly gentle. And then when we come down, we speed up. The slope is very sharp here. And then as we get past C, the slope values flatten out and become less steep or more moderate. And so the answer here would be at point C. That's where the steepest slope is occurring.